Number one here, we need to look at the equation of a circle. So the equation of a circle is x minus h squared plus y minus k squared equals the radius squared, right? So on this one, your center then is hk is your center, h comma k, that's your center, and then r is your radius. So hk in the first one here would be 2 comma 3. And then r squared, if you look at our equation, r squared is going to be 25. So if you take the square root of both sides there, the radius is going to be 5. So we have a radius of 5. And the next one, it's x plus 4. X plus 4 is the same as x minus negative 4. And then y minus k, so that would be 1, so negative 4, 1. Our r squared is 80. So if you take the square root of both sides, you get r equals the square root of 80. We can reduce that if we wanted to. So that's going to be 16 times 5. And then the square root of 16 is 4. So that's going to be 4 square root of 5. That's your reduced answer. But square root of 80 is also going to be acceptable. So square root of 80. All right, number 2. Okay, so we need the center, we need the radius, and we need, again, the equation. So maybe I shouldn't have deleted all that. Okay, so the center of our circle is negative 1, 2. Our radius is the distance from the center of the circle to the circle itself. So we need to use our distance formula. Right, so our distance formula is the change in x squared plus the change in y squared. So that's x2 minus x1 squared plus y2 minus y1 squared. Okay, so we're finding the distance between the center of the circle and a point on the circle. So if we do that, we're going to have our two x values are negative 1 and 1. So 1 minus negative 1 squared plus, and then two y values are 2 and 5. So 2 minus 5 squared. So that's going to give us 2 squared plus negative 3 squared, which is going to give us the square root of 4 plus 9, which is going to give us the square root of 13 for our radius. So over here, we're going to put in s. We type them in square root of 13. And then up here, we can type in negative 1, 2. Okay, and then when we write our equation, we're going to do x minus negative 1. So that becomes x plus 1 minus, and then h is negative 1. So minus a negative 1 becomes plus 1 squared plus it's y minus 2 squared. And that is going to equal r squared. Our radius is square root of 13. So the square root of 13 squared is going to be 13, right? If r equals the square root of 13, then r squared is going to be 13. And that's what we plug in there. All right, number 3. Okay, we have a circle. Radius 7 is centered at the origin. Does the point negative 3 square root of 2, 5 lie on the circle? Well, in order to do that, we need to substitute that coordinate into the equation and see if the equation is true or false. If it's true, then that point is on the circle. If it's false, then that point is not on the circle. So the center is at the origin, that's 0, 0. The radius here is 7, so we can type in 7, which means our equation is x squared, right? X minus 0 squared, but you don't need to write minus 0 because minus 0 means nothing. Plus y squared, again, it can be y minus 0 squared, but 0 just means nothing. Okay, equals our radius squared, which would be 7 squared, which is 49. Okay, so now what we're going to do is we're going to take that equation and we're going to plug in or substitute in the point we want to see if it's on the circle or not. We're going to take these two coordinates here. So negative 3 square root of 2 squared plus 5 squared. Does that equal 49? Okay, negative 3 square root of 2 squared. That's negative. Two negatives become a positive. 3 times 3 is 9. Square root of 2 times square root of 2 is 2. So it's going to be 18. Plus, then 5 squared is 25. So we end up with 43. Right, 18 plus 25 is 33. 43 equals 49. That is not true. And since it's not true, the point does not lie on the circle. So we're going to say no. Right? 43 does not equal 49. So the point does not result in an equation that is true. Okay, you'd have to get 49 equals 49 in order for it to work. All right, next one. Okay, find the area. So area equals pi r squared. So the area here is going to be pi times 12 squared, which is going to give us 12 squared is 144. That's going to be 144 pi inches squared. Circumference is 2 pi r. So it's going to be c equals 2 times pi times 12. 2 times 12 is 24, so it's going to be 24 pi inches. Area and circumference. All right, find the circumference of the circle given the area. So we know that the area is equal to pi r squared. So if we substitute in 16 pi for our area, we get 16 pi equals pi r squared. We divide both sides by pi. We end up with 16 equals r squared. We take the square root of both sides. We get 4 equals the radius. Okay, so 4 is the radius, 4 inches. All right, we want to find the circumference. The circumference is equal to 2 pi r. So we're going to take the radius and we're going to substitute it into the circumference formula. So that's 2 times pi times 4. 2 times 4 is 8. So it's going to be 8 pi inches. So we should put in 8 pi. All right, next one we have the area and we're finding the circumference. So we start with the circumference formula this time. Okay, 22 pi goes in for C because it's the circumference. 2 pi r. We're going to divide both sides by 2 pi. 22 divided by 2 gives us 11 for our radius. And then we're going to take that radius and we're substituting it into the area formula. So area equals pi r squared. So that's going to be area equals pi times 11 squared, and 11 squared is going to be 121 pi. 121 pi. All right, next up. We know that semicircles measure 180 degrees. So here's a 120 degree arc. So if this one right here, dB is 60, we can do 180 minus 60, which is 120. Then on the other side, we also have a semicircle. So the measured angle CE here is 90, which means 180 minus 90 gives us another right angle. So the measure of arc EB is also 90. So when we fill in here, CD is 120. BCE, so we're going from B to E, but we're going the long way through C. So that one's going to be 60 plus 120 plus 90. It's this entire arc here. Right? It's this arc here around the outside. Right? So that's 180 plus 90, that's 270. Okay, DE is going to be this minor arc here. That's 60 plus 90 is 150. And then E to C, but we're going through B. So that's 90 plus 60 plus 120 should be, again, 270. All right, number 8. Find the measure of arc AC and arc ABC. All right, so the measure of arc AC is 120 degrees. It's the same as the central angle. And then to find ADC, the long one, you have to do 180 minus 120. I'm sorry, 360. There's 360 degrees in a circle. 360 minus 120, which is going to give us 240. And then to find the arc length, we're just substituting those measures and the radius of 24 into our arc length formula. So if we write that out, arc length is x over 360 times 2 pi r. So the central angle on the first one there is going to be 120 over 360 times 2 times pi times the radius, which is 24. Then I'm going to put that in my calculator. So calculate. I have 120 divided by 360 times 2 times pi times 24. And I get 50.3. It doesn't tell us where to round. Maybe we shouldn't round. 50.3. Yep, that's fine. 50.3. All right, the green one. So the bigger arc. So we have to do 360 minus 120, right? The whole circle is 360. So 360 minus 120 is going to give us 240. So the arc length here for the green one should be 240 over 360. And then times the circumference, 2 pi, and the radius is 24. Right, so I can put that in 240 divided by 360 times 2 times pi times 24. It gives me 100.5. And that makes sense because it should be twice as big. Right? It's twice the angle measure. It should be twice as big as the other arc. Number 9, we're finding sector area. So sector area equals x over 360 times pi r squared. Okay, we have 135 degrees, so it's going to be sector area equals 135 out of 360 times pi, and then the radius here is 9, so times 9 squared. And then I'm just going to put that all in my calculator. 135 divided by 360 times pi times 9 squared, and I get 95.4. if I did it right. Round to the thousands place. 3 decimals. Okay. So that should be 426. All right, and then the unshared part is the other arc here. So if this is 135, 360 minus 135 is going to be 215. Yep. 225, actually. Yeah, 225. All right, let me put that in just to make sure. 360 minus 135 is 225 degrees. So for that one, for the unshaded part, we're going to do, let's do a different color. We're going to do 225 over 360, and then times the whole area, which is pi r squared, so pi times 9 squared. So let's put that in our calculator. 225 divided by 360 times pi times 9 squared. And I get 159.043. 159. All right, that's good there. Whoops, clear. Number 10. Let's see if I can use the equation one here. So we know arc length equals x divided by 360, and then 2 pi times the radius. Okay, find the radius of a circle that has a sector area. So actually we're using sector area here. So let's redo that. Sector area equals x divided by 360, and then times pi r squared. So we're solving for radius, so we have a sector area of 9 pi, so we're going to plug in 9 pi for sector area equals, and then x is going to be 90 degrees, so 90 divided by 360, and then pi r squared. All right, let's reduce the 90 over 360. So that's going to be 9 pi equals 1/4. And then pi r squared. I'm going to multiply 4 on both sides. Okay, so if I multiply that on both sides, I'm going to end up with 36 pi equals pi r squared. Okay, I'm sorry, r squared, pi r squared. All right, and we're going to divide both sides by pi now. And when you divide both sides by pi, it's going to cancel out, and you're left with 36 equals r squared. You take the square root of both sides, and you get 6 equals r. So hopefully our answer is 6 for the radius, and it is. All right, question 11. Find the radius of a circle which has an arc length of 9 pi meters, whose central angle is 90. So this time we're doing the same thing, except we're going to use the arc length formula, which is what I started doing first on the other one. So arc length equals x divided by 360, and then times 2 pi times r. So the arc length is 9 pi, so we're going to plug in 9 pi for the arc length. And then 90 over 360. And then times 2 pi r. Okay, this one we can reduce again, so 9 pi. Pi equals 1/4. 2 pi r. Okay, I'm going to multiply both sides by 4. That's going to give me 36 pi equals 2 pi r. So what I'm going to do now is I'm going to divide both sides by 2 pi. That cancels. The pi's here cancel. And then 36 divided by 2 is 18. So I'm left with 18 equals r. 36 divided by 2 is 18. All right, that's 11. Okay, number 12, we need to find the area of the sector and then the area of the triangle and then subtract them. So the area of the sector is our sector area formula. So sector area is going to be equal to 90 over 360 times pi, and then your radius here is 8 from the center to the circle itself, so times 8 squared. And you put that in our calculator, that's going to be 16 pi. But 390 divided by 360 times pi times 8 squared, 50.3. And that would be centimeters squared. Okay, but we got to now find the area of the triangle, the white space here, and we need to subtract it from the area of the sector. So the area of a triangle is 1/2 base times height. So that's going to be 1/2 8. And then the height is also 8 because 8 is the radius. So 1/2 and then 8 times 8, that's 64 times 1/2, which is going to give us 32. And that's 32 centimeters squared. Okay, so the red here is going to be the entire sector area. All of this, right? And then the blue is going to be just the area of the triangle. So if we take the area of the red and subtract the area of the blue, all we're going to have left is that shaded region. So let me take my calculator. 50.3 minus 32 is going to be 18.3. You don't even need the calculator for that one. Yep. All right, 3 more. So the next one is completing the square. So the first thing we're going to do is rewrite the equation, and we're going to subtract 28 from both sides. So minus 28 minus 28. So I'm going to have x squared, x squared plus 4x plus y squared minus 12y. So we're going to subtract 28 from both sides, so that's going to be equals minus 28. Okay, in our equation, we need to complete the square. So, what we're going to do here, let me actually rewrite this down here as another one. Okay, is we're going to need to add. So in order to do this, we need to take the b, which is 4, divide by 2, and square it. So if you divide 4 by 2, that's 2, and then 2 squared is 4. So right here, we need to add 4. And if you add 4 to the left, you need to add 4 to the right to keep the equation balanced. Okay, for the y's, the b is negative 12, so we're going to divide by 2, that's negative 6. And then square it, that's going to be 36. So we need to add 36 to this side, and if we add 36 to that side, we need to add it to the other side as well. Okay, now we can factor our perfect squares. So if we look here at the first 3 terms, x squared plus 4x plus 4, that's going to become x plus 2 squared. Plus, and then that y, so negative 12 divided by 2 is negative 6, so this should be y minus 6 squared. And that equals negative 28 plus 4 plus 36 is going to give us 12. What that means is that the center of the circle is going to be negative 2, 6. and the radius is going to be the square root 12. You could break that down into 2 root 3 if you wanted. Right? 2 square root 3, but that's fine. Square root 12. Okay, for the next one, we're going to do the same thing. All right, so let's do red here. I'm going to subtract 12 from both sides. So I have x squared plus y squared. I'm going to put my minus 8x over here. Minus 8x. And then equals negative 12. We move the 12 over to the other side. Okay, the y's are good. It's just y squared. That's y minus 0 squared. X, though, we have to factor into a perfect square. So we have x squared minus 8x. We need to divide negative 8 by 2. That's negative 4, and then square it. So that's plus 16. And if you add 16 to the left, you need to add 16 to the right. So now we can factor that. That's going to become x minus 4 squared plus y squared equals negative 12 plus 16 is 4. That means our radius is the square root of 4, which is 2, and the center is 4, 0. All right, and that is 13. 14. Okay, so the goat is tethered to a pole 60 feet away, so it's going to go a little bit past on this side, and it's going to go probably double on this side. Can we move this if we... Nope. All right, we're going to have to try and hand draw a circle here. Let's see. I don't know. I don't know, that looks pretty good.